Introduction to Mechatronics. In this unit, we will study about Introduction to Mechatronics, conventional mechatronic and mechatronics approach in designing products, mechatronics design process, mechatronics in manufacturing, adaptive and distributor control systems, modeling and simulation of mechatronic systems. Let us see definition of mechatronics. Mechatronics is normally described as synergistic combination of mechanics, electrical, electronics, computer and control, which when combined make possible the generation of simple, more economic and reliable systems. The term mechatronics was first assigned by Mr. Tetsuro Mori, a senior engineer of Japanese company in Yasakawa in 1969. It is a multidisciplinary approach to the product and manufacturing system design. See the picture 1. Mechatronics can also be termed as replacement of mechanics with electronics or enhance mechanics with electronics. For example, in modern automobiles, mechanical fuel injection systems are now replaced with electronic fuel injection systems. This replacement made the automobiles more efficient and less pollutant. With the help of microelectronics and sensor technology, mechatronic systems are providing high levels of precision and reliability. It is now possible to move in XY plane in the work table of modern production machine tool in a step of 0.0001 mm. By employment of reprogrammable microcontrollers and microcomputers, it is now easy to add new functions and capabilities to product or a system. Today's domestic washing machines are intelligent and four-wheel passenger automobiles are equipped with safety installations such as airbags, parking or proximity sensors, anti-theft electronic keys, etc. Mechatronics brings together areas of technology involving sensors and measurement systems, drive and actuation systems, and microprocess systems together with the analysis of behavior of the systems and control. Now you see the picture of basic elements of mechatronic systems shown on the screen. Next we will see about the conventional mechatronics approach in designing products. See the picture, the differences between the conventional mechatronics approach in designing products is shown on the screen. Customers are demanding more variety and higher levels of flexibility in the products. Due to these demands and competition in the market, manufacturers are thriving to launch new or modified products to survive. It is reducing the product life as well as lead time to manufacture a product. It is therefore essential to automate the manufacturing and assembly operations of a product. There are various activities involved in the product manufacturing process. These activities can be classified into two groups: YD, design and manufacturing activities. Now you see the picture 4 of design process. In design process, mechatronics concurrently employs the discipline of mechanical, electrical, control and computer engineering at the stage of design itself. Mechanical discipline is employed in terms of various machines and mechanisms, whereas electrical engineering has various electric prime movers, YD, AC, DC servo motors, and other systems is used. Control engineering helps in the development of various electronics based control systems to enhance or replace the mechanics of mechanical systems. Design process. The computers are widely used to write various softwares to control the control systems, product design and development activities, materials and manufacturing, resource planning, record keeping, market and other sales related activities. Next, we will see elaborate steps followed in design process. There are some sequence of steps to be followed in designing a product or anything. First one, the need. Second one, analysis of the problem. Third one, preparation of a specification. Fourth one, generation of possible solutions. Fifth one, selection of a suitable solution. Sixth one, production of a detailed design. Seventh one, production of working drawings. Then first one, the need. The design process begins with the need from. Second, the analysis of the problem. The first stage in developing a design is to find out the true nature of the problem, that is, analyzing it. If not defining the problem accurately, it can lead to wasted time on designs that will not fulfill the need. Third one, preparation of a specification. Following the analysis, a specification of the requirements can be prepared. First, subdivision 1. State the problem. Subdivision 2. Any constraints placed on the solution. Subdivision 3. The criteria which may be used to judge the quality of design. Subdivision 4. All the functions and desirable features required for the design. Next is fourth step. The generation of possible solutions. Here it may be also called as conceptual stage. Outline solutions are prepared which are worked out in sufficient detail to indicate the means of obtaining each of the required functions. Example, approximate sizes, shapes, materials and costs. Fifth one, selection of a suitable solution. The various solutions are evaluated and the most suitable one selected. Evaluation will often involve the representation of a system by model and then simulation to establish how it might react to inputs. Sixth step, production of a detailed design. The detail of the selected design has now to be worked out. The production of prototypes or mock-ups in order to determine the optimum details of the design. Seventh step, production of working drawings. Selected design is then translated into working drawings, circuit diagrams, etc., so that the item can be made. Next, we will see evolution levels of mechatronics. There are 4 levels we are calling. First one is primary level mechatronics, second, secondary level mechatronics, and then tertiary level mechatronics and quaternary level mechatronics. In the primary level mechatronics, which integrates electrical signaling and mechanical action at the basic control level, for example, fluid valves and relay switches. In the secondary level mechatronics, which integrates microelectronics into electrically controlled devices, for example, cassette tape player. Tertiary level mechatronics, which incorporates advanced control strategy using microelectronics, microprocessors, and other application of specific integrated circuits, for example, microprocessor based electrical motor used for actuation purpose in robots. Quaternary level mechatronics. This level attempts to improve smartness a step ahead by introducing intelligence, that is artificial neural network and fuzzy logic, and fault reduction and isolation capability into the system. Next, we will see about advantages of mechatronics system. The products produced are cost effective and of very good quality. The performance characteristics of mechatronics products are such which are otherwise very difficult to achieve without synergistic combination. High degree of flexibility. A mechatronics product can be better than just some of its parts. Greater extent of machine utilization. We are aware that there are many advantages if we follow in mechatronics, but very small disadvantages. Disadvantages: high initial cost of the system, imperative to have knowledge of different engineering fields for design and implementation. Specific problems for various systems will have to be addressed separately and properly. It is expensive to incorporate mechatronics approach to an existing or old system. Introduction to mechatronics.